Hello everyone, welcome back. In this vignette, I'm going to cover generators, and I'm going to do so by providing an example, a function called inclusive range generator. This vignette is intended for my students that took CEIS 110 and want to advance their studies in this journey towards learning to program in Python. So the generator creates an iterator, and it generates an iterable value on the fly, and that is key. By doing this value on the fly, your code will be more memory efficient because it generates values on the fly instead of returning all the values at once. It uses a keyword called yield. Because it creates an iterator, it can be used for for loops, as I will show in my example. I offer you some references. There's some Python documentation, my GitHub, username Outreviso, where I have a repository called Python and a folder called Python vignettes. All right. There you will also find another related Jupyter notebook called Python iterator vignette inclusive range that does exactly what I'm going to be doing here, except it does it with a class called for an iterator, an inclusive range iterator class. Also, follow me on my GitHub and subscribe to my playlist. Alright, where you will find these videos and other related videos. So the key concepts that we will cover are iterable, iterators, and generators. Right. So we already cover iterable and iterators. An iterator has a method called next, so to go through the iterations. A generator is more memory efficient, and it returns an iterator, so the next method is implicit, and you will see that when I go through my example. It generates elements on demand, and it uses a yield keyword. So let's go to my example. You can see here I define a new function called inclusive range generator with a start and end. It's basically going to do the same that the range function does in the built-in function from Python, except in range, the end is not included. So if you say range 0, 10, it'll give you and return 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It counts 10, but it includes the 0, so it stops at 9. It returns a 9, it doesn't return the 10. In my case, just to be unique and to use it as an example, I'm going to return all the numbers, 0 and 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and also 10. All right, so it is a function, it's documented here. It has inputs, start and end, they're numeric integers, and it will yield or return a variable called current underscore number, which is the number that is going to return through that sequence. Those are the elements generated on the fly. On lines 13, 14, and 15, I simply have some error handling techniques in case the user doesn't pass integers to this function. All right, so the fun begins on line 17. On line 17, I assign the value of start to the current number. Then I go through a while loop, and the while loop is going to be yielding back the current number to the caller, to the caller of this function. And as it goes through this while loop, it's going to increase by 1. The current number is an integer, so it's going to increment it by 1. And it's going to continue incrementing it. It's going to allow it to be equal to the end. Therefore, it's going to yield also the end. That's why it's inclusive range generator. But once it passes the end, it's going to stop. It's going to stop the loop. So that's basically what it's going to do. The while loop will terminate once the current number exceeds the end. And that means that it doesn't go through this yield current number. The last it does for yield current number is when current number is equal to end. That's the last one. So that's how the function works. I have the description here documented for you, which is what I just described in words. Then I'm going to call it. I'm going to call it, and I'm going to start in this example 5 to 15, and I call it within the for loop. So I say for number in inclusive range generator. So what's happening here, the for loop is going to call my generator right there, and whatever it gets yield is going to be passed to number. And then I'm going to print it so that I can show you what I'm getting. I'm going to pass a start and end value, which I define here 5 and 15. So what happens is the inclusive range generator is going to create an iterator, basically, which will contain a next function, a next method. And that next method is going to be utilized by the for loop to get the next value, right? So that's how it's going to work. I have the detailed description of the for loop sequence right here, but basically what is happening, right, it's going to be calling, it's going to call this function, and it's going to be getting the next value and the next value and the next value. It's going to be incrementing the yield. It's going to return the yield. That's the next value becomes the, what is yield becomes the next value, basically. And then the for loop is going to be printing it right here as it goes through the loop. Now, one thing that is interesting here is that once the while loop ends, if I go back to the function, the while loop is going to end, then implicitly, the generator implicitly creates a stop iteration. And as you recall, the stop iteration is at the end of the iterator, is when the iterator no longer is iterating anything for you, it sends an exception called stop iteration. So it's going to do it the same way here. The for loop will handle the stop iteration and it will stop the loop. So let's run this code. First, let's go back and let our computer know about this function. So let's run the first line, the first cell right here. So I just ran it and it took it. No errors, nothing. And so my code already knows, the computer already knows that we have a function called inclusive range generator, right? My kernel is already aware of it. And now I'm going to utilize it. So let's do that. Bam. So here we go. It did what we expected. It goes and starts going through the loop. And as it goes through the loop, it's going from start to end value. 5, 6, 7, 8, 9, 10, all the way up to 15, including the 15. So there you go. So that is your example of a generator, right? So you may start using it in your own code, but even if you don't, you may see it in somebody else's code. You may see it in an example from class. In fact, in class, if you go back to CEIS 110, we did use a generator in there when we were taking weather data from the NOAA using an API, and we had a generator in there that I can make a reference to. So you can go back to your notes in CEIS 110, and you will find a generator. But regardless, moving forward, as you go through learning more code in other classes or doing a project and investigating about Python, most likely you will come across generators. They are very useful. They are a lot of fun. They can do a lot of things for you. And I hope this was valuable for you. Again, follow me on GitHub and subscribe to my YouTube channel. I'll talk to you later. Take care. Bye-bye.